Have you ever wondered what makes the universe sparkle, colours pop, and life itself possible? Light isn't just what lets us see. It's energy, history, and even a messenger from the farthest corners of space. From the glow of a firefly to the light of distant galaxies, photons shape everything around us. Let's dive into 100 fascinating facts about light and discover the hidden stories carried in every beam. Fact 1. Light, the energy that shapes everything. Have you ever noticed how light changes the way the world feels? A gloomy day can make everything look dull, but a single ray of sunshine suddenly makes the same street come alive. Light doesn't just help us see, it defines how we feel, what we grow, and even how life itself exists. Without it, everything would simply stop. Light is energy in motion. It shapes our days, our moods, and our planet's very balance. The warmth of the sun powers winds, fuels rain, and feeds plants through photosynthesis. Every bite of food we eat, every colour we admire, every reflection in a mirror, all trace back to light's endless journey through space. What's even more amazing is that light connects the entire universe. The glow from distant stars that died millions of years ago still travels across time to reach your eyes. Think about that. Some of the light hitting your face tonight might have started its journey before humans even existed. It's like time itself leaving clues for us to find. Every technology we rely on, from fibre optics to smartphones, depends on light in some way. Even the internet, those invisible waves bouncing between satellites and your phone, is really just light communicating in disguise. And when you think about it, light doesn't just shape our physical world, it shapes our understanding of it. Because without light, we'd have no way to see the truth. Fact 2. What exactly is light? If someone asked you, what is light, you'd probably say, something that lets us see. Fair answer, but it's so much more than that. Light is energy that travels in waves, carrying information, warmth, and colour all at once. It's not made of matter. You can't touch it or weigh it, yet it's powerful enough to carve shadows and burn through space. Light is actually made of tiny particles called photons. But here's the twist. Photons don't behave like regular objects. They act like both waves and particles at the same time. That's strange, right? Imagine a tennis ball that can go through 2 doors at once. Then decide afterward which one it actually went through. That's how weird light can be. And still, we rely on it for everything, from the rhythm of our days to the electricity in our cities. Plants use light to grow, animals use it to hunt or hide, and humans use it to explore the stars. Even our sense of time, day and night, exists because of light's rhythm. So, the next time you switch on a lamp, remember, you're not just lighting a room, you're working with one of the most mysterious forces in the universe, something that's been shining, bending, reflecting, and revealing the world since the dawn of time. Fact 3. Light is a wave and a particle. Here's one of science's strangest riddles. Light behaves like a wave and a particle, both, at the same time. It sounds impossible, but experiments keep proving it. As a wave, light ripples through space just like sound moves through air. Those waves can interfere, overlap, and bend. That's how we get things like rainbows and reflections, light's waveside in action. But then, in other experiments, light behaves like a stream of particles, tiny packets of energy called photons. These photons can knock electrons loose from metal, power solar panels, or even trigger your phone's camera sensor. So which one is it? Wave or particle? Both. Light doesn't choose, it just is. And that's what makes it one of nature's great paradoxes, something that refuses to fit into a single definition. Einstein used this mystery to help explain the photoelectric effect, a discovery that changed physics forever. Today, that same principle is what makes modern technology work. Solar cells, fibre optics, and even laser scanners. The next time you see sunlight sparkling on water, remember, those shimmering ripples aren't just beautiful, they're waves and particles dancing together in perfect harmony. Fact 4. How fast does light really travel? Let's play a quick imagination game. You flick on a lamp and instantly the light fills the room. It feels instant, but it isn't. Light actually moves at a finite speed, about 300,000 kilometers per second. That's fast enough to circle the Earth more than 7 times in just 1 second. But even at that unbelievable speed, light takes time. Sunlight, for example, takes roughly 8 minutes to reach us. So when you look at the sun, you're seeing it as it was 8 minutes ago. Look at the nearest star and you're seeing light that left years ago. Look at distant galaxies. You're seeing light from millions, even billions of years in the past. Every starry night, sky is really a window into time itself. That's how astronomers study the universe. They're not watching what's happening now. They're watching history written in light. And if you think that's mind-blowing, wait until you realize that this speed isn't just fast, it's the limit. Nothing can outrun it, not even your imagination. Fact 5. The speed limit of the universe. Light doesn't just move fast, it defines fast. According to Einstein's theory of relativity, nothing in the universe can go faster than light. It's the cosmic speed limit, built into the very fabric of reality. When something moves close to your light speed, weird things happen. Time slows down, mass increases, distance itself warps. For the traveller, seconds might pass, while years slip by for everyone else. It's not science fiction, it's physics. Light moves through empty space effortlessly, carrying energy and information across unimaginable distances. It connects galaxies, planets, and people. It's the messenger of the cosmos, the reason we can see stars that died long before Earth even formed. Scientists have spent centuries trying to understand if there's any way to break that limit, but so far light always wins. It's the fastest, most untouchable thing we know. So the next time you stare at the night sky, remember this. The beams of light reaching your eyes have been racing for millions of years, never slowing, never stopping. And in all that vastness, not a single thing has ever been able to catch them. Fact 6. The journey of a photon. Imagine this. A single particle of light, called a photon, is born inside the heart of the sun. It starts as pure energy in a chaotic, blinding storm of nuclear fusion. But before it can escape into space, that photon faces the most unpredictable obstacle course in the universe. It bounces, billions upon billions of times, for thousands of years. Yes, you heard that right. Thousands of years. A photon can spend up to 1,000,000 years just trying to get out of the sun. It ricochets off atoms, gets absorbed, re-emitted and scattered in every direction imaginable. It's like trying to run across a crowd at a concert where everyone keeps bumping into you. Then one day, after an eternity of collisions, the photon finally breaks free. It bursts from the sun's surface and rockets through space at the ultimate speed, 300,000 kilometers per second. 8 minutes later, it touches your skin as warmth or glimmers on the ocean's surface as golden light. And that's not the end of its journey. Some photons travel even farther, through space past planets, stars, and galaxies. They cross billions of light years, carrying stories from the dawn of time. When they finally reach Earth, we use telescopes to catch them and decode their message. What stars are made of, how galaxies move, even how the universe began. So next time you stand in sunlight, think about it. The light warming your face might have been trapped inside the sun long before humans even existed. Every photon has a story, and somehow it found its way to you. Fact 7. Light from the beginning of time. The light that fills our universe has been travelling for nearly 14 billion years. It's the oldest thing we can see, older than stars, older than planets, older than life itself. After the Big Bang, the universe was a foggy, hot soup of particles. No light could escape. It was trapped, bouncing endlessly in the dense plasma. Then, about 380,000 years later, something incredible happened. The universe cooled enough for atoms to form, and suddenly, light was free to travel for the very first time. That ancient glow still exists today. We call it the cosmic microwave background, the faint afterglow of creation. Scientists can still detect this light with special telescopes. It's not bright or colourful. It's a whisper, stretched thin by time and distance. But in that faint radiation lies a record of everything. How matter formed, how galaxies took shape, how the universe grew. It's like a baby picture of existence itself. When we look at that ancient light, we're not just seeing space, we're seeing history. Every faint photon from the cosmic background has been travelling since the beginning, never slowed, never stopped. It's the universe's first message, still reaching us today. Fact 8. Why the sky is blue. Ever wonder why the sky isn't green, purple, or pink? The answer lies in how sunlight interacts with the air around us. When sunlight enters Earth's atmosphere, it encounters molecules of nitrogen and oxygen. These tiny particles scatter the light, breaking white sunlight into all its colours, but blue light waves are shorter and scatter more easily than red ones. So, as sunlight spreads through the air, blue gets tossed around in every direction, filling the sky with that soft, endless colour we see above us. That's why the sky looks blue during the day. It's not that the air is blue, it's just how light behaves when it dances through our atmosphere. And when you look up, you're actually seeing sunlight that's been bounced off trillions of air molecules before reaching your eyes. Every piece of blue sky is light that's taken the scenic route. If Earth had a different atmosphere, the colour could change entirely. On Mars, for example, the sky can look reddish, or even butterscotch because of the dusty air. Here on Earth, we just happen to have the perfect mix of air and sunlight to paint our world in blue. Fact 9. Why sunsets glow red and orange. There's something almost magical about a sunset. The colours, the calm, the way everything slows down for a moment. But behind that beauty is pure physics. As the sun sinks lower in the sky, its light has to travel through more of Earth's atmosphere. Along the way, those tiny air molecules scatter the shorter blue wavelengths of light out of your line of sight. What's left are the longer wavelengths, reds, oranges and golds, that make the sunset glow. The more dust, smoke, or moisture in the air, the deeper those colours can become. That's why sunsets often look more intense after a rainstorm or during a hazy summer evening. The particles in the air give light more to bounce off, painting the sky in fire. So when you watch the horizon burn with colour, you're really watching the end of sunlight's journey through the day, its last few rays stretched, scattered, and softened by the air. And for a few minutes light itself seems to pause, to breathe, to say goodbye. Fact 10. The colour spectrum, hidden in white light. White light might look simple, but it's actually a perfect mix of every colour imaginable. When Isaac Newton first passed a beam of sunlight through a glass prism in the 17th century, he discovered something astonishing. White light isn't pure. It's a rainbow in disguise. Inside that beam are all the colours of the visible spectrum: red, orange, yellow, green, blue, indigo, and violet. Each colour represents a different wavelength of light. Red has the longest, slowest waves. Violet has the shortest and most energetic. When white light passes through something that bends it, like glass, water, or even a raindrop, it splits into those colours because each wavelength bends at a slightly different angle. That's how rainbows form in the sky after rain. Sunlight enters a drop of water, bends, reflects inside, and emerges as a fan of colour. Every screen, light bulb, and even your own eyes work by blending those wavelengths back together. Your brain takes millions of signals from the cones in your eyes and turns them into the colours you see every second of the day. So, when you look at a rainbow or even a simple beam of sunlight, remember, white light isn't empty. It's the universe's way of hiding all the colours of creation in one shining package. Fact 11. Ultraviolet light, the invisible force. You can't see it, but it's everywhere. Ultraviolet light, UV for short, is a kind of light that sits just beyond the violet edge of the visible spectrum. It's invisible to the human eye, yet it plays a massive role in life on Earth. The sun bathes our planet in ultraviolet rays every day. Some of those rays are helpful. They trigger your skin to make vitamin D, which keeps your bones strong and your immune system balanced. But too much exposure can be dangerous. UV rays can damage skin cells, causing sunburns, premature aging, and even cancer if we're careless. Still, this invisible light isn't the villain it's often made out to be. It's actually one of nature's powerful tools. Bees, for example, can see ultraviolet patterns on flowers that guide them to nectar, like glowing runway lights only they can detect. Many birds and insects rely on UV to navigate, hunt, and communicate. Scientists have found incredible uses for it too. Hospitals use UV lamps to sterilize equipment and kill bacteria. Forensic investigators use UV light to reveal clues invisible under normal light. Even those glowing nightclub posters? That's UV magic too, making certain pigments light up like neon fire. So while we may not see ultraviolet light directly, it constantly interacts with our world. It protects, it reveals, it heals, and, if we're not careful, it can also burn. It's a reminder that not all light shines where we can see it. Fact 12. Infrared light. Heat you can't see. Have you ever stood in front of a campfire and felt its warmth without touching it? That's infrared light at work, the invisible energy that carries heat through the air. Infrared light lies just beyond the red end of the visible spectrum. We can't see it, but we can feel it on our skin. Everything warm, your body, your coffee mug, even your laptop, gives off infrared radiation. It's light we can't see, but our senses recognize it as warmth. Animals are especially good at using infrared. Snakes like pit vipers can detect infrared heat from prey in total darkness, allowing them to see the body heat of a mouse even at night. Some night vision cameras do the same thing, translating infrared waves into glowing images so we can see in the dark. Infrared light also plays a big role in science and technology. Astronomers use infrared telescopes to look through dust clouds in space and spot stars that visible light can't reach. TV remotes, security systems, and even your phone's facial recognition all rely on this invisible wavelength. So the next time you feel the sun's warmth or sit by a glowing heater, remember, you're surrounded by light you can't see, but your body knows it's there. Infrared is the warmth of the universe wrapping around everything even when the world looks dark. Fact 13. X-rays. Seeing through the unseen. There's something almost magical about seeing what's hidden beneath the surface. That's exactly what X-rays let us do. They're a form of light, yes, light, that's powerful enough to pass through soft tissue, but gets absorbed by denser materials like bone or metal. When Wilhelm Röntgen discovered X-rays in the late 19th century, it was by accident. He noticed that a fluorescent screen nearby glowed even though it wasn't exposed to visible light. Curious, he experimented, and suddenly he saw the bones of his wife's hand shining on a photographic plate. The world had just discovered how to see inside itself. Today, X-rays are everywhere, in hospitals, airports, even outer space. Doctors use them to check for fractures, dentists to inspect teeth, and astronomers to study violent cosmic events like black holes and supernovae. But X-rays also remind us of light's strange dual nature. They behave like waves and particles carrying massive energy in tiny bursts. That power is both useful and dangerous, which is why doctors step behind a shield before taking an X-ray image. Every time you look at an X-ray, you're looking at light that's literally gone through you. Light that reveals, heals, and helps us understand what our eyes can't. A kind of light that doesn't just shine, it penetrates. Fact 14. Gamma rays, the most powerful light of all. If light had a wild side, gamma rays would be it. These are the most energetic, most dangerous, and most mysterious form of light in existence. They carry so much power that a single burst from space can outshine an entire galaxy for a few seconds. Gamma rays are born in the most extreme events imaginable: supernova explosions, colliding neutron stars, and even the decay of radioactive atoms. They're invisible to us, but their presence can change everything. Too many gamma rays can destroy cells, damage DNA, and wipe out life. But used carefully, they can also save it. Doctors use controlled doses of gamma radiation to kill cancer cells in the body, targeting disease with precision that surgery alone can't match. Gamma rays sterilize medical equipment, preserve food, and help researchers study the universe's most violent moments. Space telescopes like NASA's Fermi detect gamma ray bursts, cosmic fireworks that tell us how stars die and galaxies evolve. Each burst carries ancient energy from billions of light years away, flashing for just moments before fading forever. So, gamma rays remind us that light isn't always gentle. Sometimes it's fierce, explosive, and raw, the universe's way of flexing its power. Fact 15. Radio waves, the longest light waves in the universe. When you turn on the radio, stream a podcast, or check your Wi-Fi, you're using light, just not the kind you can see. Radio waves are the longest form of light in the electromagnetic spectrum. Their waves can stretch for meters or even kilometers at a time. These long waves travel easily through the air, through walls, and even around the curve of the Earth. That's why radio signals can cross oceans, and why we can communicate with spacecraft billions of kilometers away. In the early 20th century, scientists like Heinrich Hertz and Guglielmo Marconi discovered how to send information using these waves, and the world changed forever. Suddenly, we could transmit voices, music, and data through thin air. Every form of wireless communication we have today, radio, television, Wi-Fi, GPS, even cell phones, is powered by invisible radio light. But radio waves aren't just for communication. Astronomers use massive radio telescopes to listen to the universe. They detect faint signals from distant galaxies, pulsars, and even the cosmic background radiation, the echo of the Big Bang itself. So the next time you tune into your favorite station or connect online, remember, you're literally surfing light. It might be invisible, slow, and soft-spoken, but it carries the voices of the world and the whispers of the cosmos. Fact 16. Microwaves. Cooking with light. You probably don't think of your microwave oven as a light machine, but that's exactly what it is. When you pop popcorn or reheat leftovers, you're actually cooking with a form of invisible light. Microwaves. Microwaves are a type of electromagnetic radiation, just like visible light, radio waves, and X-rays. The difference is their wavelength. Microwaves have waves longer than infrared but shorter than radio waves. And those specific wavelengths happen to do something pretty incredible. They make water molecules move. When microwaves pass through food, they cause the water molecules inside it to vibrate billions of times per second. That rapid motion generates heat which spreads through the food, cooking it from the inside out. No flames, no stovetops, just light doing all the work. But microwaves aren't just for kitchens, they're also the backbone of modern communication. Your phone's Wi-Fi, satellite TV, radar systems, they all use microwaves to send information invisibly through the air. Astronomers even study faint microwaves that come from the early universe, the cosmic microwave background, the leftover glow from the Big Bang. So next time you watch your dinner spin in the microwave, remember, you're not just heating food, you're harnessing one of the universe's most versatile kinds of light, a light powerful enough to cook your meal and carry signals from the edge of space. Fact 17. Polarized light. The secret sunglasses. Trick ever put on a pair of polarized sunglasses and notice how the world suddenly looks clearer, calmer, and sharper. That's not just good design, it's science. Polarized light is light that's been filtered so that its waves move in only one direction. Normally light waves scatter in all directions, but when light reflects off surfaces like water, glass, or roads, those waves can align in certain angles, creating glare. Polarized lenses block that glare by only letting through light waves traveling vertically. It's like turning down the chaos and bringing order to what your eyes see. This trick isn't just useful for humans. Many animals naturally detect polarized light. Bees use it to navigate even when clouds hide the sun. Fish and cuttlefish use it to spot prey, hiding under reflective water surfaces. To them, the world looks organized in a way we can barely imagine. Polarization is also used in technology. 3D movies rely on polarized glasses to separate two overlapping images, one for each eye. LCD screens, camera filters, and even scientists studying the atmosphere all depend on the same principle. So when you slip on those shades and watch the world suddenly shimmer less and sparkle more, you're not just protecting your eyes, you're bending light's behavior in your favor. That's the secret power of polarized light. Fact 18. Refraction. When light bends. Have you ever looked at a straw in a glass of water and noticed how it looks broken or bent? That's refraction, light's way of playing tricks on us. When light passes from one medium to another, like air to water or glass, it changes speed. And when speed changes, direction changes too. The light bends. That bending creates some of the most beautiful effects in nature. Rainbows exist because of refraction, sunlight bending inside raindrops, separating into colors. Even lenses in your eyes rely on refraction to focus light onto your retina. Without it, the world would look blurry and out of focus. Scientists use refraction in all kinds of technology. Cameras, microscopes, telescopes, and glasses all depend on it. Fiber optic cables use tiny amounts of refraction to keep light signals bouncing inside them, carrying your internet at light speed. And here's something poetic. Refraction also lets us see into water, but it deceives us too. Fish aren't actually where they appear to be when viewed from above. That's why spearfishing is so hard. You're seeing light that's been bent on its way to your eyes. Refraction shows us that even light, which seems so straight and simple, can twist and turn depending on where it travels. It's not an illusion. It's light's graceful way of changing direction when the world around it changes. Fact 19. Reflection. The mirror's magic. Stand in front of a mirror and you're face to face with one of light's most fascinating tricks, reflection. It's simple but profound. Light hits a surface and bounces back. But what it reveals is extraordinary. When light rays hit smooth surfaces like glass, metal, or still water, they reflect in predictable angles. That's why you can see your face in a mirror but not in a rough wall, because rough surfaces scatter light in too many directions for an image to form. Reflection has shaped how humans understand the world. Ancient people gazed into pools and thought reflections were spirits or portals. Artists learned to capture reflections to make paintings come alive. Scientists used mirrors to build telescopes that let us see galaxies billions of light years away. And it's not just beauty, reflection powers technology. Periscopes, cameras, and lasers all rely on it. Even the retroreflectors left on the moon by astronauts still bounce laser beams back to Earth today, allowing us to measure the distance to the moon with centimeter precision. Every time you see your reflection, you're not just looking at yourself. You're seeing how light remembers where it came from. A mirror doesn't just reflect your face, it reflects the story of light's return journey home. Fact 20. Diffraction. Light's ripple effect. Light doesn't just travel in straight lines, it also bends, spreads and ripples around obstacles. That's diffraction. It's one of the reasons light can fill a room, even when it passes through a tiny crack. Imagine throwing a pebble into a pond. The ripples spread out, curving around rocks and edges. Light behaves the same way when it encounters small openings or objects near its wavelength. The waves bend slightly, creating delicate patterns of bright and dark fringes, like light's version of water waves. You've probably seen diffraction without realizing it. The rainbow colors on a CD, or the shimmer of a soap bubble come from light bending and interfering with itself. In labs, scientists use diffraction patterns to study the structure of atoms, proteins, and even DNA. Diffraction also helps explain why shadows aren't perfectly sharp. Light doesn't stop cleanly at edges, it softens, spreading gently into nearby space. In the vastness of the universe, diffraction shows us that even something as fast and straight as light can be gentle and flexible. It reminds us that light doesn't just illuminate, it adapts, dances, and paints the world with patterns only physics can explain. Fact 21. How rainbows are made. Have you ever finished a rainstorm and looked up to see that perfect half arc of colour stretched across the sky, and thought, how on earth did that happen? It's like the sky suddenly decided to wear a multicoloured smile. Well, here's the story. Sunlight is white light, and when it shines through the sky while rain is still falling, tiny droplets of water act as miniature prisms. When sunlight enters a water droplet, it slows down a little because the droplet is denser than air, so the light bends. That's refraction. Inside the droplet, the light reflects off the back of it. Then when it exits, it bends again. In that journey, the white light splits into all its component wavelengths: reds, oranges, yellows, greens, blues, indigos, violets, because each wavelength bends at a slightly different angle. The result? From your vantage point, you see light that matches a set geometric angle, about 42 degrees for red, a bit less for violet, reaching your eye from many droplets. That makes the circular arc we call the rainbow. Here's a little everyday twist. The rain has to be behind you, the sun in front of you, low in the sky usually, and the raindrops between you and the sun must be backlit. What you see isn't a fixed place. If you walk toward the rainbow, it moves away, because it's based on your perspective and the exact geometry of light and droplet. So next time you spot that iconic arc, remember each tiny droplet is doing that three-step dance: refraction, reflection, refraction, separating white light into its hidden rainbow palette and ending up in your eye. In other words, Nature, optics, and you all working together. Fact 22. Double rainbows. What's really happening? So you're admiring a rainbow and then, wait, there are two arcs. Double rainbows feel magical, and they are, both in appearance and in physics. The first, lower brighter arc is what we discussed earlier. The second arc, above the first and fainter, appears because the light inside those droplets does an extra reflection before exiting. Instead of one bounce inside the drop, it's two bounces. That extra reflection means more light is lost, so the bow is dimmer. And the colour order reverses. The outer arc has red on the bottom and violet on the top. If you imagine it, sunlight enters droplet, refracts, reflects twice inside, refracts out. You see the second arc. That extra internal journey flips the angular geometry, and thus flips the colours. It's a beautiful metaphor too. The second bow is fainter, but it reminds us that sometimes the echo of something is quieter, reversed, but still meaningful. And if you ever catch both arcs shining after a storm, pause a moment. You're watching two stories of light in the same sky. Fact 23. The Northern Lights. Earth's light show. Here's a scene. You're standing under a night sky, far north, and suddenly the darkness ripples with waves of green, pink, purple light. It's the aurora borealis, also known as the Northern Lights. It's nature's cosmic laser show, but with no wires. What's going on? Well, our sun constantly throws out a stream of charged particles, electrons and protons, called the solar wind. When those particles reach Earth, they crash into our planet's magnetic shield. That shield guides many of them toward the polar regions. Then when those charged particles hit the gases in our upper atmosphere, like oxygen and nitrogen, they transfer energy, and boom, light. That's what creates the aurora. Different gases at different altitudes glow different colours. Green is common, oxygen at 100 kilometers. Reds can appear at higher altitudes or under intense conditions. It's more than just pretty. It's a reminder that light isn't only about the visible spectrum or everyday sunshine. It's about energetic particles, magnetic fields, space weather, and this gigantic dance between sun and earth. And when you narrate this in your script, remind the listener, when they see the northern lights, they're looking at invisible physics made visible. Fact 24. The Southern Lights. Aurora's twin. If the northern lights are one sibling, then the aurora australis, southern lights, is the other, dancing in the skies over the Antarctic regions or southern high latitudes. Same physics, mirrored in the south. Sun throws charged particles. Earth's magnetic field channels them toward the poles. Particles meet atmosphere. Gorgeous lights. Same loop as the north. Because of geography, fewer people get to see them compared to the north. But when you do, you feel it. The whole sky becomes alive and you realize how connected we are. Planet, sun, space. Also a nice connection. You can reference the Northern Lights story, Fact 23, and then say, there's a South Hemisphere version, just as wild, just as meaningful. In your script, you could make it feel personal. Imagine yourself on a quiet beach in Tasmania or Chile, watching the waves and above, like curtains of green and purple shifting. It's not just science, it's memory, presence, wonder. Fact 25. Bioluminescence. Living creatures that glow. We go from sky and space to sea and life. Light isn't only in stars and optics, it's inside living creatures. Some plants, fungi, insects, and many deep-sea animals produce their own light. That's bioluminescence. Here's what happens. Inside their bodies they have a chemical called luciferin, with an enzyme called luciferase, or sometimes a photoprotein. That luciferin reacts with oxygen and sometimes other cofactors and produces light, with almost no heat, cold light. Why do they glow? Some use it to attract mates, fireflies, others to lure prey, deep-sea anglerfish, some to warn predators or camouflage in the ocean's dark counter-illumination. Picture a warm summer night with fireflies shimmering in the field, or a midnight kayak through waters where luminescent plankton light up each paddle stroke like stardust. All of these are living organisms wielding light. In your script you might talk about how light is not just passive, it's alive. It's used, changed, controlled by life. It bridges nature and physics in the most elegant way, and it brings the story full circle, from photons racing across galaxies to tiny creatures glowing in the ocean's depths. Fact 26. Fireflies, nature's tiny lanterns. On a warm summer night, you step outside and the air seems to sparkle. Tiny golden lights flicker on and off in the darkness, like nature's own Morse code. Those are fireflies, or lightning bugs, and they've been enchanting people for thousands of years. But what's really happening inside those little glowing bodies? The secret lies in a chemical reaction called bioluminescence. The same phenomenon we explored earlier with deep-sea creatures. Fireflies produce light using a compound called luciferin and an enzyme named luciferase. When oxygen mixes in, it triggers a reaction that releases energy in the form of visible light, not heat. That's why scientists call it cold light. Unlike a candle or a bulb, the firefly's glow doesn't waste energy. Nearly 100% of it turns into light. Talk about efficiency. Humans still can't match that. And what are they flashing for? It's not just decoration. Those blinks are love signals. Each species of firefly has its own rhythm, a kind of glowing language. Males flash in a specific pattern while flying, hoping a female of the same species will recognize the signal and flash back. It's communication through pure light. There's also a bit of trickery involved. Some fireflies mimic the flashes of other species to lure them closer, not for romance, but for dinner. Light, in this case, becomes both attraction and deception. So the next time you see a meadow filled with flickering dots, remember, you're watching a conversation, one made entirely of light, chemistry, and life. Fact 27. Glow-in-the-dark minerals. Imagine walking into a cave and seeing rocks glowing in shades of blue. Green and violet. No batteries, no lamps, just their own mysterious light. Glow-in-the-dark minerals, or fluorescent minerals, reveal that even the Earth can shine. The trick lies in their atomic structure. Some minerals contain impurities or activator elements like manganese, uranium, or europium. When ultraviolet light, invisible to us, hits these minerals, their atoms absorb that energy, then release it back as visible light. That's why they seem to glow under a black light. You've probably seen this in museums, cases of stones glowing bright green or hot pink when the UV lamp turns on. But nature does it too. Certain calcites, fluorites and willamites light up in caves and mines around the world. There's also something called phosphorescence, where a mineral continues to glow even after the light source is gone. It's slower, the atoms release their stored energy gradually. That's the science behind glow-in-the-dark toys or stars you stick on your ceiling. So yes, even rocks can perform a kind of magic, not with fire, but with physics. Beneath the surface of the Earth lies a hidden rainbow, waiting for the right kind of light to set it free. Fact 28. The science behind neon lights. Think of a rainy night in a big city. Neon signs buzzing above the streets, glowing pink, red, blue, green. Words floating in the mist. It feels alive, electric, and a little nostalgic. But what's actually glowing up there? Neon lights work on a beautifully simple principle. Electricity excites gas atoms. Inside each glass tube is a small amount of gas, neon, argon, helium, krypton, and when electric current passes through, it energizes the gas atoms. Those atoms then release that energy as visible light. Pure neon gas glows red-orange, that classic neon color. To get other hues, different gases or phosphor coatings are used. Argon with mercury, for example, gives a cool blue light, while helium can produce yellow or pink tones. The technology dates back to the early 1900s. When Georges Claude demonstrated neon lights in Paris, people were stunned. Light without flame, steady and bright. Soon, cities like Las Vegas and Tokyo became glowing jungles of color. Beyond their beauty, neon lights changed communication. They turned words into light. Signs became beacons. Today, even LED signs owe part of their design philosophy to those original glowing tubes. Fact 29. Lasers light with precision. The word laser sounds futuristic, but it's actually an acronym. Light amplification by stimulated emission of radiation. That's a mouthful. but what it really means is concentrated, perfectly organized light. Unlike ordinary light, which spreads out and contains many wavelengths, a laser produces a beam that's narrow, focused, and made of a single wavelength. It's like all the photons are marching in perfect step, coherent and powerful. Lasers were first built in the early 1960s, and at first no one knew what to do with them. But today, they're everywhere. In medical surgery, barcode scanners, communication fibers, and even the mouse under your hand. A laser works by trapping light inside a cavity between mirrors. Each photon triggers more photons of the same energy and direction, a chain reaction of perfect alignment. When enough energy builds up, the light escapes through one mirror as a focused beam. Lasers can cut through steel, read data off a disk, or guide spacecraft millions of miles away. But the real wonder is this: a laser is just light behaving with absolute discipline, a cosmic orchestra of photons all playing the same note. Fact 30. Fiber optics. Light becomes communication. Every time you send a message, stream a video, or make a video call, you're using light, even if you don't see it. That's the miracle of fiber optics. Fiber optic cables are thin strands of glass, sometimes thinner than a human hair, that carry information as pulses of light. Instead of electricity running through copper wires, light signals bounce their way through these transparent fibers, traveling enormous distances almost instantly. The magic lies in total internal reflection. When light hits the inner surface of the fiber at just the right angle, it doesn't escape. It reflects and keeps moving down the core. This means signals can travel for miles with barely any loss. Each pulse of light represents digital information, the ones and zeros that make up everything from emails to entire movies. Thousands of these signals can flow through a single strand simultaneously, at speeds close to the speed of light. This technology revolutionized communication. It's how continents are connected through undersea cables. It's what powers the global internet. So next time you watch a video or call a friend across the world, remember, it's not magic, it's light. Bent, reflected, guided, and transformed into the language of connection. Fact 31. How light powers solar energy. Every time sunlight hits your skin, it carries enough power to light up the world, literally. That same sunlight falling on rooftops across the planet is what powers the solar revolution. But how does a ray of light become electricity? It all starts with the photovoltaic effect, a fancy term for how light knocks electrons loose. Inside a solar panel, you'll find many smaller units called solar cells. These are made from materials like silicon, which are semiconductors. When sunlight hits the surface, its photons transfer energy to the electrons in silicon atoms. Those electrons get excited and start moving, and moving electrons mean electricity. The process is silent and clean. No smoke, no burning fuel, just sunlight being turned into energy through physics and clever design. Once those electrons start flowing through a circuit, they can power homes, charge batteries, and even run cities. The idea isn't new. Scientists discovered the photovoltaic effect in the 1800s, but it wasn't until the space race that solar panels really took off. They were perfect for satellites where regular fuel couldn't reach. Today, that same technology is on rooftops, farms, and even backpacks. The beauty of solar energy is that it's endless. Every hour, the Earth receives more energy from the sun than humanity uses in a whole year. We just need to keep getting better at capturing it. So next time you see a solar panel shimmering in the sun, think of it as a translator, turning light, the purest form of energy, into the language our machines understand. Fact 32. Photosynthesis. How plants eat light. You and I eat food. Plants eat sunlight. That might sound poetic, but it's literal science, and it's the foundation of life on Earth. Photosynthesis is how plants turn light energy into chemical energy. Inside their leaves are tiny green structures called chloroplasts, which hold a pigment named chlorophyll. This pigment absorbs sunlight, mostly blue and red light, and uses it to power a chemical reaction that turns carbon dioxide and water into glucose, food for the plant, and oxygen, the air we breathe. Think about that. Light, water, and air become the basis of every meal on the planet. Whether it's a tree, a flower, or a single blade of grass, each one is a living solar panel, quietly converting sunlight into energy. It's one of the most elegant systems ever created. Plants store that energy in the form of sugars, and animals, including us, borrow it when we eat them. So, in a roundabout way, everything you've ever eaten began as sunlight. When you walk through a forest, you're surrounded by trillions of tiny chemical factories, each one catching light, turning it into life. That's the magic of photosynthesis, nature's oldest, most efficient solar technology. Fact 33. The human eye. How we see the world. Your eyes are like biological cameras, except they're much more advanced. Every second, they turn light into pictures, colour and depth. But how do they do it? When light enters your eye, it passes through the cornea, pupil and lens before landing on the retina, a thin layer at the back lined with special cells called photoreceptors. There are two main kinds, rods and cones. Rods are responsible for seeing in low light. They can't detect colour but are super sensitive to brightness. Cones, on the other hand, handle colour vision. You have three types, one for red, one for green, and one for blue. When light hits them, they send electrical signals through the optic nerve to your brain. And that's where the real magic happens. The brain interprets those signals and turns them into the vivid, moving world you see. It's not just copying reality, it's constantly correcting, adjusting, and filling in gaps. That's why you don't notice the blind spot where your optic nerve connects, or why illusions can trick you. So next time you admire a sunset or stare at your reflection, remember, what you're seeing isn't just light. It's your brain's masterpiece, painted with photons and perception. Fact 34. The colours. You don't really see. You probably think you see every colour there is, but your eyes are actually missing a huge part of the light spectrum. Humans can only see what's called visible light, a tiny slice between ultraviolet and infrared on the electromagnetic spectrum. That's roughly from violet light, about 400 nanometers, to red, around 700 nanometers. Beyond those boundaries, light still exists. We just can't see it. Bees can see ultraviolet light. Snakes detect infrared. Some birds can spot patterns on flowers invisible to humans. The truth is, we live in a world that's much more colourful than we realise. Our eyes just weren't built to see all of it. Even with invisible light, your perception of colour isn't absolute. The colour of an object depends on the light around it. That's why a shirt can look blue in daylight but grey indoors. Your brain constantly adjusts for context, a process called colour constancy. So the next time you argue over whether something is blue or green, remember, colour isn't really in the object. It's in the light, your eyes, and your mind. We don't see reality as it is. We see the light our biology allows us to see. Fact 35. How animals see. Light differently. Imagine seeing a world painted in ultraviolet, or watching heat shimmer like colour. For many animals, that's not imagination. That's everyday vision. Bees, butterflies, and birds can see ultraviolet patterns on flowers that guide them to nectar. Invisible road signs written in light. Snakes like pit vipers use infrared sensing to detect warm-blooded prey even in darkness. Cats and dogs don't see the full rainbow we do. They're mostly sensitive to blues and yellows, but their eyes are built for motion and low light, giving them far better night vision. Owls have huge eyes packed with rods, allowing them to see clearly in near darkness. Some deep-sea creatures have evolved eyes that detect the faintest glimmers of blue light, the only colour that penetrates deep ocean water. Others, like mantis shrimp, have vision so complex that they can detect types of light polarization we can't even imagine. It's humbling, really. We often think our vision defines the world, but to other species, our world looks completely different. Light is everywhere, but every creature reads it in its own way. Fact 36. The mantis shrimp's supervision. If you think humans see the world in colour, wait until you meet the mantis shrimp, nature's visual overachiever. Our eyes have 3 types of colour receptors: red, green, and blue. That's enough to make a rainbow of colours, but the mantis shrimp, it has 16. 16 different kinds of colour receptors that open up a world of hues we can't even imagine. To this small but mighty crustacean, the ocean must look like a living kaleidoscope, ultraviolet, polarised, and full of shimmering details invisible to us. What's even more fascinating is that scientists once believed this shrimp could distinguish colours far better than we could. But experiments revealed something strange. Even with 16 receptors, the mantis shrimp isn't necessarily better at telling colours apart. It's just faster. Its eyes are built for quick recognition, not careful comparison. It's like having a shortcut. The shrimp doesn't analyse, it reacts. That's crucial when you live in a world where every split second can mean life or death. And its eyes, they're on stalks that move independently, scanning the water with military precision. Each eye can gauge depth on its own, which gives it a kind of built-in 3D vision. So when the mantis shrimp strikes, and it can strike with the speed of a bullet, it never misses. Light for this creature isn't just beauty, it's a weapon, a warning, and a way of life. Fact 37. Ultraviolet patterns on flowers. To us, flowers are colourful and bright, but to a bee, they're even more alive. Many flowers hide special ultraviolet UV patterns on their petals, invisible to human eyes. These markings act like landing lights, guiding pollinators straight to the nectar. Imagine a runway glowing with hidden arrows. That's what a daisy or sunflower looks like under UV light. Plants evolved these secret signals for survival. The patterns tell bees exactly where to go, ensuring pollination happens efficiently. Some flowers even change their UV patterns, depending on whether they've already been visited, signaling to bees that there's no more nectar left. It's a silent conversation in light, happening right beneath our noses. The next time you walk through a garden, remember, you're seeing only half the story. The other half glows in a light your eyes can't detect, but nature's pollinators depend on it completely. Fact 38. How bees see what we can't. Bees see a world of colour that's completely different from ours. They can't see red, but they can see ultraviolet. That means flowers that look ordinary to us burst with secret patterns in their vision. These patterns are nature's way of saying, this way to the nectar. Through ultraviolet light, bees can navigate, identify species, and even tell time. They use the polarization of sunlight, something we can't perceive, to orient themselves when flying. It's their built-in GPS. Scientists have even discovered that bees can detect the electric fields around flowers, helping them sense whether another bee has recently visited. To a bee, the world isn't dull or grey, it's alive with glowing paths and electric whispers. Light to them is more than brightness, it's communication. Fact 39. Night vision. Seeing without light. At night, when the world turns dark to us, many animals still see clearly. Owls, cats and snakes have evolved ways to use every bit of light available, even when it's barely there. Their eyes are equipped with special cells called rods, which are incredibly sensitive to dim light. An owl, for example, can see a mouse moving hundreds of feet away in near total darkness. Cats have a reflective layer behind their retinas called the tapetum lucidum. That's what makes their eyes glow in headlights. It bounces light back through the retina, giving them a second chance to see it. And then there's the infrared vision of snakes, detecting body heat instead of visible light, a completely different kind of sight. It's a reminder that seeing doesn't always mean seeing light the way we do. Nature finds a way to turn even the faintest glow into survival. Fact 40. The science of shadows. Shadows. They seem simple, but they're one of the most fascinating effects of light. A shadow forms when an object blocks light's straight path, but not all shadows are the same. The closer the object is to the light source, the sharper and darker the shadow becomes. Move it away, and the edges blur, fading softly into the surroundings. Astronomers use shadows to measure the size of planets. Ancient civilizations used them to tell time with sundials. Even artists rely on shadows to create depth and emotion in paintings. Without shadows, light would have no meaning. It's the contrast that gives shape to the world. And in space, shadows can stretch for thousands of kilometers. On the moon, for instance, they're pitch black and razor sharp because there's no air to scatter the sunlight. Light and shadow together don't just reveal, they define everything we see. Fact 41. Total darkness. Does it truly exist? Close your eyes and imagine complete darkness. Not the kind you get in your bedroom at night, but a true, absolute void. No light at all. Can it even exist? In theory, yes. In reality, it's almost impossible to find. Even in the deepest caves, where sunlight never reaches, the air can still carry traces of bioluminescent fungi, or microscopic life that glows faintly. Scientists have built special rooms called anechoic chambers, places designed to absorb all light and sound. Step inside one, and you'll feel disoriented, even dizzy. Your eyes search for something, anything to reflect light. But there's nothing. After a few minutes, your brain starts to make up its own faint patterns of light just to stay grounded. Even in the depths of space, where no stars shine nearby, there's still a whisper of light. Stray photons, cosmic background radiation, the faint afterglow of creation itself. So, true darkness. It's more of an idea than a place. The universe doesn't like being empty. Even in its darkest corners, light refuses to fully die. Fact 42. Light in deep space. Deep space isn't as dark as it seems. Between the stars and galaxies, tiny bits of light drift endlessly, remnants from suns long dead, and from galaxies billions of light years away. Space telescopes, like the Hubble and James Webb, can capture these ancient rays, turning faint whispers into breathtaking images. This light travels for eons through nothingness. Some photons, the particles of light, have been journeying since before our planet even formed. Each one carries a piece of history, a record of where it's been. When scientists study this faint light, they're literally reading the story of the universe written across time. So even when space looks black to our eyes, it's actually glowing with a soft, eternal shimmer, too weak for us to see, but always there, like the memory of creation itself. Fact 43. The first light in the universe. Long ago, the universe was dark, utterly and completely. After the Big Bang, it took about 380,000 years for the first light to appear. Before that, everything was an opaque soup of particles. Light couldn't move freely. It was trapped, bouncing endlessly between matter. Then, the universe cooled. Atoms formed. Suddenly, light could travel. The first beams stretched freely across space, filling it with radiance for the very first time. This was the dawn of illumination, the moment the cosmos became visible. That first light still exists today, though it's stretched and cooled by the expansion of the universe. We can't see it with our eyes, but telescopes can detect its faint glow, a cosmic memory billions of years old. It's the universe's oldest photograph, frozen in time, reminding us how everything began. Fact 44. Cosmic microwave background, the glow of creation. When scientists point radio telescopes into the sky, they detect a faint uniform glow coming from every direction. That glow is the cosmic microwave background, the afterlight of the Big Bang. It's the oldest light we can ever see, born when the universe was just a baby. This light is incredibly faint, stretched into microwaves after nearly 14 billion years of expansion, but it carries clues to everything. The shape of the cosmos, its age, its fate. It's like reading the birth certificate of the universe. Discovered accidentally in 1965 by Arno Penzias and Robert Wilson, this discovery confirmed the Big Bang theory. The static they heard on their antenna wasn't noise, it was the echo of creation itself. Every time we study it, we're peering back to the moment when everything began to shine. Fact 45. Light from distant galaxies. When you look up at the night sky, you're not seeing the stars as they are, you're seeing them as they were. Light takes time to travel, and even though it moves incredibly fast, it still takes years, sometimes billions of years, to reach us. That means when we observe distant galaxies, we're literally looking back in time. The light from some galaxies began its journey before Earth even existed. Each photon crossed unimaginable distances, passing through cosmic dust warped by gravity, stretched by the expansion of the universe, and yet it still found its way to us. Modern telescopes like the James Webb can capture this ancient light in stunning detail, showing us galaxies that formed shortly after the dawn of time. Every tiny speck of light in those images represents billions of stars, entire worlds, perhaps with their own skies, suns, and stories. In the grand picture of the cosmos, light is the messenger, the only traveller that tells us what the universe once was. Fact 46. Redshift. When light stretches across time. Imagine watching a car drive away from you. Its engine sounds deeper and lower as it moves farther. That's the Doppler effect. Light behaves the same way. When galaxies move away from us, their light stretches, shifting toward the red end of the spectrum. We call this redshift. This cosmic stretching isn't just a neat trick, it's proof that the universe is expanding. Every bit of space between galaxies is growing, and the light travelling through it gets stretched too. The farther away something is, the redder its light becomes. Astronomers use this effect like a cosmic ruler to measure distance and time. The light from the most distant galaxies has been travelling for billions of years. When we see their faint red glow, we're looking back to a time when the universe was young, almost newborn. Redshift turns the night sky into a time machine, letting us glimpse the earliest moments of everything we know. Fact 47. Blue shift, the cosmic compression. Now imagine the opposite. Something racing toward you. The sound rises in pitch, and light shifts toward blue. That's called blue shift. When a star or galaxy moves closer, its light waves get compressed, and the colour leans toward the blue end of the spectrum. Here's the twist. While most of the universe is expanding away from us, some galaxies are actually getting closer. The Andromeda Galaxy, for example, is on a slow collision course with our Milky Way. Its light is blue shifted, showing us it's approaching at hundreds of kilometers per second. Blue shift gives astronomers a way to track movement and direction in the vast sea of space. It's like the universe's built-in navigation system, showing which cosmic neighbours are heading our way, and which are fading into the distance forever. Fact 48. Light from black holes. The paradox of darkness. Here's something wild. Black holes don't let light escape, yet they can still shine. How? It's all about the edge, the event horizon. As gas and dust spiral toward a black hole, they heat up to millions of degrees, releasing light and energy just before vanishing forever. This creates a glowing halo called an accretion disk. We can't see the black hole itself, but we can see this brilliant ring around it. That's how the first real image of a black hole, the one in the galaxy M87, was captured in 2019. It wasn't a photo of the darkness, but of light fighting its last battle against gravity. Even stranger, black holes can emit faint radiation called Hawking radiation, meaning they slowly lose mass over billions of years. So the ultimate paradox is this: even the darkest place in the universe isn't entirely without light. Fact 49. Gravitational lensing. Light, bent by gravity. Light always travels in straight lines, unless gravity gets in the way. Massive objects like galaxies or black holes can bend the path of light passing nearby. This is called gravitational lensing, a phenomenon predicted by Einstein's theory of relativity. When it happens, light from a distant galaxy gets curved around a massive object between it and us. The result? The same galaxy appears distorted, magnified, or even duplicated in our telescopes. It's like nature's own magnifying glass, bending space-time itself. Astronomers use this cosmic lens to study things that would otherwise be too far or too faint to see. It lets us peek at galaxies from the earliest ages of the universe, brought closer by the invisible pull of gravity. In a strange way, the universe uses its own gravity to help us see its secrets. Fact 50. The edge of the observable universe. If light travels at a fixed speed, and the universe has an age, that means there's a limit to what we can see, a cosmic horizon. The farthest light that's reached us has been travelling for nearly 14 billion years. But because space itself is expanding, that edge now lies about 46 billion light-years away. Beyond that, we simply don't know. Light from farther regions hasn't had time to reach us yet. There may be countless galaxies, stars, and worlds out there, invisible for now, waiting for their light to finally arrive someday. So when you look up at the night sky, you're not just seeing stars, you're seeing the limits of visibility, the very edge of human perception. The universe might go on forever, but light sets our boundary, and beyond that line lies everything we can only imagine. Fact 51. How light affects our mood. Have you ever walked outside on a bright sunny day and instantly felt more awake, happier, and alive? Or noticed how gloomy grey skies can make you feel sluggish or sad? That's light at work, not just illuminating your surroundings, but also influencing your brain chemistry. Sunlight stimulates the production of serotonin, a neurotransmitter that regulates mood, focus, and happiness. More sunlight often means higher serotonin levels, which explains why people feel more energetic and cheerful on sunny days. Conversely, less sunlight can reduce serotonin and even contribute to feelings of depression. There's also something called melatonin, the hormone that controls sleep. Light suppresses melatonin production, which is why exposure to bright light during the day keeps you alert and awake. At night, darkness allows melatonin to rise, signaling your body it's time to rest. In essence, light is like nature's mood switch, a constant dialogue between your eyes, brain, and the environment. Even a short walk outside can be enough to reset your mood and energy levels. It's remarkable how something so ordinary, something we often take for granted, can profoundly affect how we feel. Fact 52. Circadian rhythms. How light controls. Sleep. Your body has an internal clock ticking away in roughly 24-hour cycles called the circadian rhythm. Light is the master regulator of this rhythm, telling your body when to sleep, wake, eat, and even release hormones. When morning light hits your eyes, it signals your brain that it's time to be alert. This suppresses melatonin and raises cortisol, preparing you for the day. As the sun sets, the dimming light cues your body to relax, letting melatonin rise and preparing you for rest. Disruptions in light exposure, like staying up late with bright screens, can throw your circadian rhythm off balance. This can lead to poor sleep, fatigue, and even metabolic issues over time. That's why doctors emphasize natural light during the day and darkness at night. It keeps your internal clock running smoothly. In short, light doesn't just show you the world, it tells your body when to experience it. Your daily rhythm is synchronized to sunlight, guiding everything from energy levels to sleep cycles. Fact 53. Seasonal affective disorder. When light heals, some people notice a change in mood when seasons shift. Shorter days and weaker sunlight in winter can trigger seasonal affective disorder, SAD, a type of depression linked to light exposure. Symptoms include low energy, irritability, and difficulty concentrating. The treatment is surprisingly simple: light therapy. Special lamps mimic natural sunlight, helping to reset serotonin and melatonin levels. Just a few minutes a day can drastically improve mood and energy. Sunlight itself is the best remedy, but for those in darker climates, artificial light can act as a lifesaver. SAD reminds us that humans are deeply connected to the cycles of the sun. Even in modern life, our bodies are tuned to light, not clocks. When light disappears, our mental and physical health can feel the void. Conversely, restoring it, even artificially, brings balance and vitality. Fact 54. Artificial light. Changing human life. Imagine life before electricity. Once the sun set, darkness ruled. But artificial light changed everything. From candles and gas lamps to electric bulbs, humans could work, read, and socialize after dark. Light extended productivity, safety, and culture. However, artificial light also altered our biology. Evening exposure to bright light can disrupt circadian rhythms, suppressing melatonin and making sleep harder. City dwellers experience light pollution, where the night sky is drowned in unnatural glow, disconnecting us from the natural cycles we evolved to follow. Yet artificial light has enabled progress. Medicine, technology, and entertainment all rely on it. It's a double-edged sword, a powerful tool that illuminates both opportunity and challenge in human life. Fact 55. LED revolution, energy through light. LEDs, light-emitting diodes, are tiny, efficient sources of light that are transforming our world. Unlike incandescent bulbs, LEDs convert electricity into light with minimal heat loss. That makes them energy-saving, long-lasting, and versatile. They're everywhere now: streetlights, homes, screens, and even plant-growing farms. Beyond efficiency, LEDs can be tuned to different wavelengths, which is essential for things like horticulture, health, and even therapy. Some LEDs can mimic natural sunlight, supporting circadian rhythms indoors. The LED revolution shows that light isn't just for seeing, it's a tool for energy, health, and innovation. By controlling it carefully, we can illuminate our lives while conserving the planet's resources. Fact 56. The birth of the light bulb. Imagine a world where darkness ruled after sunset. Streets empty, work halted, and families huddled around candles. That was the reality until the late 1800s, when inventors raced to create a practical, reliable source of electric light, the light bulb. Thomas Edison is the name most of us associate with the invention, but the story is more of a relay race than a solo effort. Many inventors, including Humphrey Davy, Warren de la Rue, and Joseph Swan, experimented with electric lighting before Edison perfected a bulb that could burn steadily for hours. He tested thousands of materials for filaments before settling on carbonized bamboo, a choice that could last over 1,000 hours. The light bulb didn't just illuminate homes, it revolutionized society. Factories could operate longer, streets became safer at night, and cities extended their hours of activity. Edison's bulb was the spark that shifted humanity from the rhythm of the sun to the rhythm of electricity. It's remarkable to think that something we now take for granted, flipping a switch, was once the forefront of technological revolution. Light had finally been tamed, allowing people to reshape life itself. Fact 57. Edison and the Battle of Currents. When Edison lit up the world, he wasn't just inventing a bulb, he was entering a war, the famous Battle of Currents. Edison championed direct current DC, while Nikola Tesla and George Westinghouse promoted alternating current, AC. The stakes were enormous. AC could travel long distances with less energy loss, making it ideal for cities and factories. DC, on the other hand, required power stations every mile or so. Edison launched a public campaign warning that AC was dangerous, even staging shocking demonstrations with animals to show its risks. In the end, AC won, powering cities across the globe. But Edison's contributions weren't lost. His work in electric lighting and energy distribution laid the foundation for modern electricity, showing that innovation often comes with competition, drama, and a touch of spectacle. Fact 58. The invention of lasers. The laser, light amplification by stimulated emission of radiation, sounds futuristic, and it is. But its invention in the 1960s changed everything from medicine to communication. Charles Townes and Arthur Schawlow built the first working laser, a device that produced a coherent, focused beam of light. Unlike ordinary light, which spreads in all directions, laser light marches in perfect alignment, allowing for precision and power. Initially, lasers were a scientific curiosity. Today, they cut metal, perform eye surgery, read barcodes, and carry internet data across fiber optic networks. Lasers demonstrated that light could be controlled, concentrated and harnessed, not just for illumination, but for incredible precision and utility. It was a reminder that even a familiar phenomenon like light could be pushed into extraordinary applications. Fact 59. Fiber optic internet. Light-speed data. Every time you stream a video or send a message across the globe, light is the courier. Fiber optic cables made from ultra-thin strands of glass carry data as pulses of light, bouncing through the fibers by total internal reflection. The speed is astonishing. Information travels at nearly the speed of light, allowing global communication in fractions of a second. Fiber optics revolutionized the internet, connecting continents and powering everything from video calls to cloud computing. By guiding light along glass threads, humanity turned photons into messengers of information, showing that light is not just for seeing, it's for connecting, sharing, and expanding knowledge. Fact 60. Light and medicine. Laser scans and healing light isn't just for the eye, it's a doctor too. Medical technology relies on light in countless ways. Lasers can correct vision, remove tumors, or seal blood vessels with precision. X-rays, CT scans, and MRIs use light or electromagnetic radiation to see inside the body without surgery. Even phototherapy treats conditions like neonatal jaundice or skin disorders. Light can stimulate healing, detect disease early, and guide surgeons through complex procedures. It's incredible to think that the same thing that illuminates a room can also illuminate the mysteries inside the human body. From cutting-edge lasers to gentle therapeutic lamps, light has become one of medicine's most versatile tools, turning photons into agents of life and health. Fact 61. The role of light in art. Light has always been more than just illumination. It's a tool, a mood setter, and a storyteller in the world of art. From ancient cave paintings to modern installations, artists have used light to guide the viewer's eye, highlight emotion, and create depth. In classical paintings, light can draw attention to the most important part of the scene, casting the rest into soft shadow. Religious art often used beams of light to symbolize divinity, while Impressionist painters experimented with sunlight, color, and reflection to capture fleeting moments of life. Even in sculpture, light interacts with form. The way shadows fall across a carved face or a twisting figure can make static stone feel alive. Light is not just a background, it's an active participant in the creation of meaning, shaping how the audience experiences art. Fact 62. How painters use light and shadow. Have you ever wondered why some paintings seem to jump off the canvas? A lot of that effect comes from the artist's mastery of light and shadow, also known as chiaroscuro. By balancing bright highlights with deep shadows, painters create contrast, depth, and drama. Caravaggio, for example, used extreme light against darkness to make figures emerge as if from the void. The play of shadows not only suggests three-dimensional space, but also conveys emotion. A softly lit face might suggest serenity, while harsh shadows can evoke tension or mystery. Even subtle shifts in light can change the story entirely. Artists know that by manipulating light, they can control the viewer's focus, guide their journey across the painting, and evoke feelings without a single word. Fact 63. The Renaissance and the discovery of perspective. The Renaissance wasn't just a rebirth of culture and knowledge. It was a revolution in seeing light and space. Artists like Leonardo da Vinci and Masaccio discovered linear perspective, using vanishing points and converging lines to create the illusion of depth. Light played a critical role. By observing how sunlight fell on objects and how shadows behaved, painters could recreate realistic forms and three-dimensionality on a flat canvas. This attention to natural light made scenes more believable, immersive, and emotionally engaging. Perspective and light together transformed art, turning paintings into windows through which viewers could experience entire worlds, not just static images. It was the moment when observation and imagination combined, making light both a scientific and artistic tool. Fact 64. Light in photography. Capturing time. Photography is essentially the art of catching light. Every photo is a frozen moment, sunlight, shadows, or artificial illumination captured and stored on film or a sensor. Without light, there is no photography. Early photographers spent hours arranging light, waiting for the perfect sun angle or reflecting it with mirrors. Modern photography, though faster, still relies on understanding light. Photographers play with exposure, highlights, and shadows to create mood, depth, and drama. Light can even tell a story in a single image. A shaft of sunlight cutting through a foggy morning, the soft glow of candlelight on a face, or the neon glow of a city street. Photography is, in many ways, painting with photons. Fact 65. Cinematic lighting. Emotion. Through illumination, movies are built on light. Directors and cinematographers use lighting to control what the audience feels, often without them realizing it. A dimly lit room can suggest danger, suspense, or intimacy. A bright, even glow can evoke happiness or calm. Techniques like key lighting, fill lighting, and backlighting shape the scene, highlighting characters, textures, and movement. Shadows can hide secrets or foreshadow events, while beams of light can symbolize hope or revelation. In cinema, light is not just functional, it's narrative. It guides emotion, tells stories silently, and transforms a blank frame into a living, breathing world. Every flicker, shadow, and highlight is part of the story's heartbeat. Fact 66. Stage lights. Telling stories. With colour, step into a theatre, and the story begins before a word is spoken, with light. Stage lighting is one of the most powerful tools directors have to guide the audience's emotions. A soft blue wash can evoke melancholy, while a blazing red spotlight might signal danger or passion. Lighting designers mix colour, intensity, and direction to shape each scene. Shadows can hide secrets or create suspense, and spotlights draw attention to a single performer, making them the centre of the world. Even subtle changes in brightness can shift the mood, signalling transitions or highlighting tension. The magic of stage lights lies in their ability to transform space. A simple set can feel like a vast forest or a bustling city depending on how light interacts with it. In theatre, light isn't just illumination, it's storytelling in motion, painting emotion in every hue. Fact 67. Neon art, painting with electricity. Neon lights aren't just signs on a street corner, they're a medium for artists to paint with electricity. By passing electric current through neon or other gases, the tubes glow in vibrant colours that capture attention and imagination. Artists bend, twist and shape glass tubes into words, shapes, or abstract forms, creating installations that glow with life. Neon art combines science and creativity. It's chemistry, electricity and aesthetics fused into one medium. The ethereal glow of neon has been used in advertisements, galleries, and public art, giving cities their character and defining eras, from the neon-soaked streets of mid-20th century New York to contemporary art exhibits. Neon proves that light can be both functional and expressive, a bridge between technology and human creativity. Fact 68. The magic of firelight in ancient rituals. Before electricity, fire was humanity's first controlled light source. Its flickering glow wasn't just practical, it was sacred. Across cultures, firelight played a central role in rituals, ceremonies and storytelling. From campfires under starry skies to ceremonial torches, fire created a space for community, reflection, and reverence. Its unpredictable dancing shadows sparked imagination, giving rise to myths, legends, and early forms of theatre. Firelight symbolized life, warmth, and protection. In many traditions, it was thought to connect humans to ancestors or the spiritual world. The flicker of a flame was more than light. It was a bridge between the ordinary and the extraordinary. Fact 69. Candlelight, the glow of history. Candles illuminate more than rooms. They illuminate history. For thousands of years, candles were the primary source of nighttime light, guiding scholars, artists, and families. Every flickering flame told a story of human ingenuity. Candlelight created intimacy. Its soft glow transformed spaces, casting long shadows that inspired artists and poets alike. Think of medieval monasteries, where scribes worked by candlelight to copy manuscripts, or candlelit parlours where ideas were shared over quiet conversation. Even today, candlelight carries nostalgia and warmth. It reminds us of the long journey from darkness to light, showing how humans learn to harness fire in small, controlled ways. Fact 70. The discovery of fire, humanity's first light. Fire changed everything. It was humanity's first artificial light, its first source of warmth, and the beginning of technological mastery over nature. Early humans discovered fire from natural sources, lightning strikes, volcanic activity, and eventually learned to control it. With fire, humans could cook food, protect themselves from predators, and extend their activity into the night. It brought communities together around shared warmth and light, allowing culture, language, and social bonds to flourish. Light from fire was also a symbol of knowledge and survival. It turned darkness from a threat into a canvas for life and creativity. The discovery of fire marked the first step in our long journey to control and understand light, from the flicker of flames to the brilliance of electric bulbs and lasers. Fact 71. Light in religion and symbolism. Throughout human history, light has symbolized more than illumination. It has represented the sacred, the divine, and the eternal. In countless religions, light embodies purity, hope, and the presence of higher powers. Temples, churches, and shrines often incorporate light to create awe and focus the mind, using candles, lamps, or stained glass to shape spiritual experiences. In many traditions, light is contrasted with darkness, symbolizing knowledge over ignorance, good over evil, or life over death. From the eternal flame in ancient temples to candlelit vigils, light has always been a bridge between the material world and the divine. Its glow draws people together, guiding rituals, prayers, and meditations. Light reminds us that humans instinctively associate illumination with clarity, truth, and transcendence, a universal language across cultures. Fact 72. The light as a symbol of knowledge. We often talk about shedding light on a subject or seeing the light when we finally understand something. This isn't just a metaphor, it's rooted in centuries of experience. Light has always represented knowledge, insight, and discovery. Ancient libraries, scholars, and philosophers often worked by daylight or candlelight, equating illumination with understanding. In literature and philosophy, darkness symbolizes ignorance, while light reveals truth. Even today, the idea persists. A bright mind, a flash of insight, or the light bulb moment all connect learning with light. Our brains, like our eyes, crave illumination. Light has become the ultimate metaphor for curiosity and wisdom, linking physical perception with mental clarity. Fact 73. Festivals of Light. From Diwali to Hanukkah. Around the world, cultures celebrate light through festivals that honor life, hope, and renewal. Diwali in India fills homes with lamps, candles, and fireworks, symbolizing the victory of light over darkness. Hanukkah in Jewish tradition celebrates the miracle of a small flame lasting 8 days, emphasizing endurance and faith. Other cultures have their own luminous celebrations: lantern festivals in East Asia, candlelit vigils across Europe, and solstice traditions marking the return of the sun. These festivals show that light is more than physical. It's deeply emotional and symbolic, a universal way to celebrate resilience, joy, and togetherness. In every festival, light becomes a language, speaking of human triumph, memory, and hope. Fact 74. The Lighthouse. Guiding ships. Home lighthouses are more than coastal landmarks. They are lifesavers. Standing tall along dangerous shores, they shine beams of light that guide ships safely through treacherous waters. Before GPS and radar, sailors relied entirely on these beacons to navigate storms, rocky coasts, and foggy nights. The power of a lighthouse isn't just in its brightness, but in its symbolism. It represents guidance, safety, and reliability, showing that even in the darkest times light can lead the way. Their rotating beams are carefully designed to be seen from miles away, warning, protecting, and comforting travellers across the seas. Lighthouses remind us that light is both practical and symbolic, a tool for survival and a metaphor for hope. Fact 75. Starlight. Ancient navigation and dreams. Before modern technology, humans looked to the stars to find their way. Sailors navigated oceans by starlight, travellers crossed deserts guided by constellations, and explorers measured time and seasons by celestial light. Stars weren't just distant suns, they were life-saving markers and tools for survival. Starlight also inspired myths, stories, and dreams. People assigned meanings to constellations, connected human behaviour to the heavens, and used the night sky as a canvas for imagination. Even today, stargazing evokes awe, curiosity, and wonder. Light from stars bridges practical need and poetic inspiration. It guides us, teaches us, and reminds us of our place in the universe. Tiny humans looking up at infinite brilliance. Fact 76. Moonlight. The gentle reflection. Moonlight feels soft, romantic, and calming, but what we're really seeing is sunlight reflected off the moon's surface. The moon doesn't generate its own light, it borrows ours, bouncing it gently back to Earth. That faint silver glow has guided travellers, inspired poets, and comforted night wanderers for millennia. Interestingly, moonlight is about 400,000 times dimmer than direct sunlight, yet it's bright enough to cast shadows, illuminate landscapes, and even affect the behaviour of animals. Certain species, like sea turtles and nocturnal insects, rely on the subtle glow to navigate. Culturally, moonlight has been a symbol of mystery, reflection, and serenity. It reminds us that even indirect light, a reflection, can have power, guiding our nights and stirring our imagination. Fact 77. The Sun, source of all life. The sun isn't just a bright disk in the sky, it's the ultimate source of energy for life on Earth. Plants capture sunlight through photosynthesis, producing the oxygen we breathe and the food we eat. Without the sun, life as we know it wouldn't exist. Sunlight also regulates our circadian rhythms, vitamin D production, and moods. It shapes climate, weather, and ocean currents. Ancient civilizations worshipped the sun as a deity, recognizing its life-giving power. Even today, solar panels harness its energy, turning light into electricity. The sun reminds us that light is more than illumination. It's the spark that sustains ecosystems, cultures, and technology alike. Fact 78. Solar eclipses. When the light disappears. A solar eclipse is a dramatic reminder of the dance between light and shadow. When the moon passes between Earth and the sun, it temporarily blocks sunlight, casting a shadow across the planet. Day turns briefly into twilight, and the sun's corona shimmers around the dark silhouette of the moon. Eclipses have fascinated humans for centuries. Ancient cultures interpreted them as mysterious signs or messages from the universe. Today, we understand the science behind them, yet they still inspire awe. Observing a solar eclipse connects us to celestial mechanics and the delicate balance that allows life to thrive under sunlight. Fact 79. Lunar eclipses. Earth's shadow on the moon. A lunar eclipse occurs when Earth comes between the sun and the moon, casting its shadow across the lunar surface. Unlike the sharp disappearance in solar eclipses, lunar eclipses often turn the moon a deep red or copper colour, earning the nickname blood moon. This phenomenon happens because Earth's atmosphere scatters sunlight, letting only the red wavelengths reach the moon. Lunar eclipses are safe to watch with the naked eye, and have guided calendars, myths, and cultural rituals for centuries. They remind us that even in cosmic alignments, light finds a way to create beauty. Fact 80. The speed of light and time travel. Light travels fast, really fast. At nearly 300,000 kilometers per second, a beam can circle Earth 7.5 times in just 1 second. But this speed isn't just about getting somewhere quickly, it's also tied to the fabric of time. According to Einstein's theory of relativity, as you approach the speed of light, time itself slows down relative to outside observers. While we can't yet travel at light speed, the concept shows that light is not just a messenger. It's intimately connected with the universe's clock. The speed of light links space and time, letting us see the past in distant stars and imagine future possibilities. Light isn't just fast, it's a doorway to understanding the cosmos itself. Fact 81. Einstein's theory and light's role in relativity. Albert Einstein revolutionized the way we understand light with his theory of relativity. He realized that the speed of light is constant. No matter how fast you move, light always travels at the same speed. This simple idea reshaped our understanding of space, time, and motion. In Einstein's world, light is the ultimate cosmic ruler. It defines distances, governs the flow of time, and sets the universal speed limit. Objects moving close to light speed experience time differently, and space itself can bend under gravity, affecting the path of light. Relativity shows that light isn't just a tool for seeing, it's a fundamental part of the universe's structure. By studying light, we learn how time stretches, space curves, and reality itself behaves. Fact 82. Why nothing can go faster than light. Why can't anything exceed the speed of light? Einstein's equations provide the answer. As an object approaches light speed, its mass effectively increases, requiring infinite energy to go any faster. Simply put, light is the cosmic speed limit. This limit isn't arbitrary. It's built into the fabric of space-time. It keeps cause and effect in order, ensuring that events follow a logical sequence. Without this limit, physics as we know it would unravel, so while light races ahead, we're bound by its speed. It's a reminder that even in a universe of infinite possibilities, there are natural boundaries, and light sets the ultimate pace. Fact 83. Can we ever catch a photon? Photons are fast, tiny, and elusive. They travel at the speed of light and have no rest mass. In theory, you can't catch up to a photon. If you tried to move alongside it at light speed, time itself would freeze from your perspective. Scientists can manipulate photons in labs, trapping them briefly in fiber loops or slowing them down in special materials, but only relative to other objects. A photon in a vacuum is untouchable, always racing ahead. Chasing light is more than a thought experiment. It's a glimpse into the strange, counterintuitive rules of the universe. Photons remind us that some things are faster than everything else, literally unreachable, yet endlessly fascinating. Fact 84. The twin paradox. Aging at light speed. The twin paradox is a famous thought experiment illustrating relativity. Imagine one twin travels through space at near light speed while the other stays on Earth. When the traveller returns, they've aged less than the twin who stayed behind. Why? Time itself slows down for objects moving close to light speed. The faster you go, the slower your personal clock ticks relative to others. It's not science fiction, it's a real prediction verified by precise experiments with atomic clocks on airplanes and satellites. The paradox shows that light speed isn't just a number, it shapes the very flow of life and time. Racing with photons, we glimpse the universe's strange temporal rules. Fact 85. Light years, measuring the vastness of space. The universe is unimaginably vast, and the distances between stars, planets, and galaxies are too enormous to measure in kilometers or miles. That's where the concept of a light year comes in, the distance that light travels in a single year, which is nearly 10 trillion kilometers. Using light years as a unit of measurement allows astronomers to describe distances in a way that's both practical and meaningful, connecting the immense scales of the cosmos to something we can comprehend. When we say a star is 10 light years away, we're not just talking about distance, we're also peering into the past. The light leaving that star took 10 years to reach us, meaning we see the star as it was a decade ago. For more distant galaxies, the light we observe started its journey millions or even billions of years ago, long before humans existed. Every photon is a messenger from the past, carrying with it information about distant worlds and ancient cosmic events. Light years are more than a unit of distance. They're a way to tell the story of the universe. They allow scientists to measure space and time simultaneously, to understand how stars evolve, how galaxies form, and how the cosmos itself changes over eons. Without light as a universal measure, our understanding of space would remain abstract and disconnected. Light truly makes the universe understandable, even when its vastness defies ordinary human experience. Fact 86. Light delay, seeing the past in the present. Every time we gaze at the night sky, we are looking back in time. This is because light takes time to travel, and the farther away an object is, the older the light we see. Our own sun is about 8 light minutes away, meaning the sunlight that warms us began its journey 8 minutes ago. We never see the sun as it is right this moment. We always see a slightly delayed version. When observing galaxies millions or billions of light years away, this effect becomes even more dramatic. The photons reaching us left their stars long before humans walked the Earth, carrying a history of the universe itself. This light delay effectively turns the cosmos into a giant time machine. By studying distant light, astronomers can trace the formation of galaxies, the birth of stars, and the evolution of cosmic structures, piecing together the story of everything. This delay also gives us a sense of perspective. Looking at distant stars and galaxies isn't just about seeing faraway objects. It's about understanding how the universe has evolved. Each photon acts as a time capsule, linking us directly to moments that happened long ago, bridging the gap between past and present. Fact 87. How telescopes capture ancient light. Telescopes are the ultimate tools for capturing these ancient photons. They collect faint light from stars, galaxies, and nebulae that our eyes cannot detect, focusing it to reveal details otherwise invisible. From Galileo's first telescope to today's massive space observatories, humans have continuously improved these instruments to see deeper and further into space. Modern telescopes allow scientists to analyze light in exquisite detail. They can determine the chemical composition of stars, the motion of galaxies, and the age of cosmic objects. In essence, telescopes function as time machines, translating photons traveling across billions of years into knowledge we can understand. Every observation is a journey across space and time, turning invisible signals into tangible discoveries. By studying light with telescopes, humans have expanded our understanding of the cosmos, mapping the universe and uncovering secrets of its origin. Without these instruments, the vast history carried by light would remain hidden, and our knowledge of the universe would be far more limited. Fact 88. James Webb Telescope, seeing the first galaxies. The James Webb Space Telescope, JWST, represents humanity's most powerful tool for observing the early universe. Unlike its predecessors, JWST observes primarily in the infrared spectrum, allowing it to see through cosmic dust and detect the faint glow of the first galaxies formed after the Big Bang. This telescope can capture light that travelled over 13 billion years, showing astronomers stars and galaxies as they existed when the universe was young. It allows scientists to study the conditions of the early cosmos, the formation of galaxies, and the birth of stars in unprecedented detail. JWST isn't just a telescope, it's a bridge across time, giving humanity a direct glimpse of the universe's infancy. By looking at this ancient light, we learn not just about distant galaxies, but about our own cosmic origins. The photons captured by JWST carry the story of creation, evolution, and the processes that ultimately led to stars, planets, and life itself. Fact 89. The Hubble Deep Field, light from the beginning before JWST. The Hubble Space Telescope provided some of the most breathtaking images of the universe. Its deep field observations involved staring at tiny, seemingly empty patches of sky for days. The result was astounding. Thousands of galaxies, some billions of light years away, revealed in a single frame. Each photon collected from these galaxies travelled across vast stretches of space for billions of years. By studying this light, astronomers could observe the formation, evolution, and distribution of galaxies across cosmic time. The Hubble Deep Field demonstrated that even the darkest, emptiest-looking regions of space are teeming with history, carrying messages from the earliest periods of the universe. Through Hubble's lens, we not only see distant light, but also witness the narrative of the cosmos itself, a story told in photons that span both space and time. Fact 90. Future of light-based technology. Light isn't just a cosmic messenger, it's shaping the future of technology. Innovations like quantum communication, LiDAR, photonic computing, and advanced lasers are transforming industries, medicine, and everyday life. Fiber optic networks carry enormous volumes of data almost instantaneously, while modern imaging techniques allow doctors to peer inside the human body with unprecedented clarity. Even futuristic ideas such as solar sails propelled by photons rely on light to explore space. From exploring distant galaxies to revolutionizing human life on Earth, light remains a tool, a guide, and an inspiration. Its future is as bright as the photons that travel through it, promising discoveries and innovations that will continue to reshape how we understand and interact with the universe. Fact 91. Holograms. 3D light. Illusions. Holograms feel like magic, but they're really an ingenious way to manipulate light. Unlike a traditional photograph which captures only the intensity of light, a hologram records both the intensity and the phase of light waves. This creates a three-dimensional image that seems to float in space, offering a perspective that changes as you move around it. Tilt a hologram, and suddenly the object appears from a new angle, just like a real item in front of you. Holography isn't just about novelty, it's widely used in art installations, adding depth and movement to creative works. On a more practical level, holograms protect credit cards, passports, and banknotes, making it extremely difficult for counterfeiters to reproduce them. In the medical field, holograms are transforming imaging techniques, allowing doctors to study organs and complex structures in 3D without invasive procedures. Data storage is another frontier. Holographic memory systems could hold vast amounts of information in compact spaces, all because light can be encoded and reconstructed in ways electrons cannot. What makes holograms fascinating is how they reveal the versatility of light. Photons, tiny particles we usually take for granted, can be carefully arranged to form illusions that trick our eyes and minds. It's a perfect blend of art and science. You can sculpt light to create beauty, utility, and wonder all at once. Holography demonstrates that light isn't just something we see. It's something we can shape, bend, and even play with, opening doors to technologies that feel like they belong in the future. Fact 92. Quantum light. The weirdest science of all quantum mechanics turns light into a playground of the strange. Photons, the elementary particles of light, behave in ways that defy common sense. Sometimes they act like particles, bouncing off surfaces or interacting in predictable ways. Other times they behave like waves, spreading out, interfering, or even being in multiple places at once. This dual nature has puzzled scientists for over a century, challenging the very way we think about reality. Quantum light isn't just theoretical fun, It's powering some of the most cutting-edge experiments in science today. It enables secure communication systems where the very act of observing a photon can reveal whether someone is trying to eavesdrop. Quantum teleportation, once the stuff of science fiction, relies on the precise behavior of photons to transmit information instantaneously across distances. And at the core of quantum computers, photons are used to encode, move, and process information in ways that classical computers cannot. Studying quantum light forces us to rethink reality. It's proof that light is more than just a beam we see with our eyes. It's a key to understanding the deepest layers of the universe. Every photon carries a dual personality, interacting in ways that challenge intuition and opening doors to technologies and discoveries that seemed impossible only a few decades ago. Fact 93. Photons that talk to each other. In the quantum world, light particles can behave in ways that almost feel alive. Under special conditions, photons can interact and influence one another without ever touching. Scientists have created scenarios where these conversations allow photons to affect each other's behavior, an effect that forms the backbone of advanced quantum networks and computing systems. These tiny interactions could revolutionize technology. By controlling how photons talk, researchers can develop ultra-secure communication channels that are impossible to hack. They can also speed up computations for complex problems, allowing AI, simulations, and massive data analyses to run faster and more efficiently than ever before. It's like teaching light to carry not just information but understanding. These photon interactions open possibilities that stretch beyond current imagination. From cryptography to supercomputing, the ability of light to communicate could transform the way we store, transmit, and process information, all by manipulating one of the universe's fastest and most fundamental particles. Fact 94. Quantum entanglement and light. Quantum entanglement is one of the most mind-bending phenomena in physics. Two photons can become linked, so that measuring one instantly influences the other, no matter how far apart they are. Einstein famously called it spooky action at distance, and it remains one of the most mysterious features of quantum mechanics. Entangled photons are central to emerging technologies like quantum encryption and ultra-fast communication. They allow information to be shared in ways that defy classical physics, offering levels of security and efficiency previously unimaginable. Researchers envision networks where entangled photons connect devices across continents instantaneously, with no risk of interception. Entanglement reminds us that light isn't just something we observe, it's a medium for connection and interaction at a fundamental level. It blurs the lines between space, time, and information, showing that photons can link realities in ways that challenge even our imagination. Fact 95. The future of light computing. The future of computing is racing toward light. Photonic computers, which use photons instead of electrons, promise speeds far beyond today's most powerful supercomputers. Since photons travel at the speed of light with minimal heat generation, these systems can handle enormous amounts of data almost instantaneously, making tasks that would take conventional computers hours or days achievable in moments. Artificial intelligence, simulations, and complex modeling will all benefit. Photonic computers may also integrate quantum properties, combining speed with the strange efficiencies of quantum mechanics. This could unlock innovations in medicine, climate modeling, autonomous systems, and beyond. Light computing shows that photons are not just for illumination, they're a tool for shaping the next era of human capability. By harnessing light, we're building machines that can think faster, process more, and push the boundaries of what's possible, proving that the smallest particle in the universe can have the largest impact on our future. Fact 96. Light as a tool for artificial intelligence. Light is becoming a key player in the development of artificial intelligence. Photonic chips, which use light instead of electricity, can process vast amounts of data at incredible speeds, far surpassing conventional electronic processors. These chips are ideal for AI tasks that require rapid calculations like image recognition, autonomous driving, and language processing. By harnessing photons, AI systems can operate faster, cooler, and more efficiently, bringing science fiction-style intelligence closer to reality. In a sense, light is not just illuminating the world, it's illuminating the path for machines to think, learn, and interact with us in smarter ways. Fact 97. the science of invisible cloaks. Invisible cloaks aren't just magic tricks. They're based on clever manipulation of light. Scientists use metamaterials to bend light around objects, making them effectively vanish from view. These materials guide photons along curved paths, preventing them from reflecting or casting shadows. While we're not yet at Harry Potter level invisibility, experimental cloaks have made small objects disappear from certain angles or wavelengths. The science of invisibility shows that light isn't fixed. It can be guided, twisted, and sculpted in ways that challenge our perception of reality. Fact 98. Light-based weapons. Science fiction or real? Laser weapons have moved from science fiction into the real world. Military and research teams are developing systems that use concentrated light to disable drones, missiles, or other targets with pinpoint accuracy. Light-based weapons rely on immense energy and precision, demonstrating that photons aren't just harmless beams. Under the right conditions, they can be incredibly powerful. While we don't have lightsabers yet, directed energy systems show that light can become a tool for both defense and offense. It's a reminder that controlling light can change the game in ways we never imagined, turning the fundamental nature of photons into instruments of power. Fact 99. Can we create light without energy? This question touches the heart of physics. Light always requires energy. From the sun to a flashlight, photons are emitted when energy transitions occur. Electrons jump between levels. Nuclear reactions happen, or chemical bonds release energy. There's no loophole. Creating light without energy would violate fundamental laws of thermodynamics. Yet, scientists continue to find ways to use energy more efficiently, generating light with minimal waste as seen in LEDs and lasers. Even in its simplicity, light teaches us that nothing comes from nothing. Every glow has a cost, every photon a history. Fact 100. The endless journey of light. From creation to you. From the first sparks after the Big Bang to sunlight bathing Earth, light has been on a continuous journey for billions of years. Photons travel across space, bounce off planets, reflect from moons, and enter our eyes to reveal the universe in all its glory. Light shapes life, inspires art, guides explorers, and powers technology. It carries history, information, and energy, connecting everything from the smallest atoms to the largest galaxies. Every moment we see, feel, or understand something about the world, light is there. The invisible traveller linking creation to experience. Its journey never ends, and neither does our fascination with it. Fact 96. Light as a tool for artificial intelligence. Light is no longer just something we see or use to illuminate rooms. It's becoming a major player in the world of artificial intelligence. Photonic chips, which use light instead of electricity, are transforming the way computers process information. Unlike traditional electronic circuits, which rely on moving electrons and produce heat as a byproduct, photonic circuits use photons, particles of light, that travel almost instantaneously and without generating significant heat. This allows AI systems to process massive amounts of data at incredible speeds. Imagine an AI that needs to analyze thousands of images per second to identify objects, detect patterns, or make predictions. Traditional electronic processors can struggle with such enormous workloads, but light-based processors can handle them with ease. Autonomous cars, for example, require lightning-fast calculations to detect pedestrians, other vehicles, and obstacles. Photonic chips can make these calculations faster, more efficient, and more reliable, enhancing safety and performance. Language processing and real-time translation are other areas where light-driven AI shines. With photons racing through circuits, information moves faster, enabling machines to understand and respond almost instantaneously. Even more fascinating is how photonic AI can integrate with quantum computing, opening the door to capabilities that were purely theoretical a decade ago. In a sense, light is no longer just illuminating our world physically. It's illuminating the path for machines to think, learn, and interact in ways previously limited to science fiction. It's helping us build a future where AI is smarter, faster, and more responsive, all thanks to the humble photon racing through circuits. From virtual assistants to predictive healthcare, light is quietly powering the next era of intelligent technology. Fact 97. the science of invisible cloaks. Invisible cloaks have long been a dream of storytellers, but scientists are now making them a reality, at least in small ways. The key to invisibility is light itself. Using metamaterials, researchers can bend and manipulate light around an object so that it appears to vanish from view. Unlike normal materials, which absorb, reflect, or scatter light, metamaterials guide photons along curved paths, effectively wrapping the object in a cloak of invisibility. These experimental cloaks can make tiny objects disappear from certain angles or for specific wavelengths of light, such as microwaves or infrared. While we're far from full invisibility like in fantasy, these breakthroughs have profound implications. Beyond the cool factor, invisibility technology could improve optical devices, create more efficient sensors, and even enhance stealth technology in the future. The science of cloaking teaches us something remarkable. Light isn't fixed. It can be guided, twisted, and sculpted to create illusions that challenge our perception of reality. By understanding how photons move, reflect, and bend, humans are turning science fiction into science fact. What seems impossible, disappearing objects, bending light, and reshaping what we see, becomes achievable with the right combination of physics and imagination. Fact 98. Light-based weapons. Science fiction or real? Laser weapons sound like something straight out of a sci-fi movie, but in reality they're becoming increasingly real. Militaries and research teams around the world are developing directed energy systems that can disable drones, missiles, or other targets with astonishing precision. These weapons focus intense beams of light, delivering concentrated energy to a target without physical projectiles. Light-based weapons rely on extreme energy and precision. A laser can travel vast distances at the speed of light, striking a target almost instantaneously. While lightsabers remain a fantasy, current technologies demonstrate that photons aren't harmless beams. Under the right conditions, they can cut, burn, or disrupt electronics. Scientists and engineers are exploring applications for defense, aerospace, and even crowd control in non-lethal scenarios. The rise of laser technology shows how mastering light can transform the way humans interact with the physical world. Controlling photons doesn't just illuminate, it empowers. It turns one of the universe's simplest particles into a tool of power, demonstrating how understanding light can change the rules of engagement in both science and society. Fact 99. Can we create light without energy? Here's a physics reality check. Light cannot exist without energy. Every photon, from sunlight to a flashlight beam, originates from an energy transition. Electrons jump between energy levels, nuclear reactions occur in stars, and chemical reactions release photons. Without energy, no light exists. This principle is fundamental to thermodynamics and the conservation of energy. There's no loophole or cheat. Creating light without energy would break the laws of physics. Yet, scientists have found ways to use energy more efficiently, minimizing waste. LEDs, for example, convert electrical energy to visible light far more efficiently than incandescent bulbs, while lasers focus energy into precise beams for maximum effect. Every glow, from the tiniest spark to the sun's brilliance, is a story of energy transformed. Light reminds us that nothing comes from nothing, and that even the simplest photon carries a history. A journey that began with energy, travelled across space or material, and finally reached our eyes to inform, inspire, or guide us. Fact 100. The endless journey of light. From creation to you, light is the universe's eternal traveller. From the first sparks after the Big Bang to the sunlight warming Earth today, photons have been journeying across space for billions of years. Each photon tells a story of stars forming, planets orbiting, and galaxies colliding. Some photons we see left their stars long before humans existed, travelling unimaginable distances to reach us. Light shapes life, inspires art, guides explorers, and powers technology. It carries information about the universe, history, and even the conditions for life itself. Every time we see, feel warmth, or experience colour, we interact with photons that have traversed vast cosmic distances. The journey of light is endless. It connects the origin of the universe to our everyday experiences, making the invisible visible, the distant near, and the past present. From creation to you, light is a continuous bridge, reminding us that we are part of a vast interconnected cosmos illuminated by the smallest, fastest, and most extraordinary particles in existence.